Good afternoon and welcome to the third interactive session for the NPTEL course Transition Metal Organometallic Chemistry in Catalysis and Biology. So now we are the continuation with the last week, that is the metastasis reaction. So in the week 1 we have seen the Repe chemistry, the synthesis of some value added product from the acetylene derived from the coal as a non-renewable energy sources. So after that we move to our another reaction, important reaction system, that is the olefin metastasis reaction. In the last week we mainly discussed the mechanistic pathway of the olefin metastasis reaction. So first we have seen that two different types of mechanism. I will wait for 2-3 minutes. If anybody joins, then I will start discussing today's session. So I welcome everyone again to this week 3 live interactive session. Myself Shubhajit Kundu, as a second third year PhD student at IIT Bombay, hosting this session as a TA, NPTEL PMRF TA for this course. So this session is mainly conducted for clearing the doubts regarding that particular week content. If anybody have any doubt, they should ask it. If anybody know, then I will continue this session from my side. So I'll also, we have seen receiving questions from the discussion forum. If you have any question regarding this week content or assignment question problem, please post your doubt in the discussion forum. We will try to answer this question as quickly as possible. I wait for another 2 minutes, then I will start discussing this week content. With this week is we have first we continued for the metastasis reaction, and from the conclusion or mechanistic pathway we discuss some important topics of carbon chemistry, and then the importance of organometallic catalysis in metastasis reaction. Wait for Okay, as nobody joined, so let's continue this session from my side. So the last week we have seen that the mechanism of the metastasis reaction. So first we have discussed the two types of uh, mechanistic pathway was proposed. First one was the simple pairing mechanism, that is which undergo the cyclobutane intermediate. But after that, without the proper definition or proper proof of this mechanism, was not able to find. And then another mechanism come, that is the non pair mechanism, and that mechanism contain the metal carbene as an intermediate. So that mechanism later on got accepted and several with the several proof, and we are continuing with this mechanism. So that there we stopped there in the last week, and this week we have seen several different types of metastasis reaction, as well as we have discussed different types of carbene, Fischer type, shock type carbene, and we have also did a little bit of n-heterocyclic carbenes. And after that we have made our carbenes as a ligand, as a nucleophile, as a ligand to the transition metal to form as a organometallic compound which act as a catalyst in olefin metastasis reaction, that is the Graff's catalyst. So this is the overall content of this week, and now I will go the details of this week content uh, quickly through the this question answer session. I hope this question answer session will be helpful for solving your assignment problems. Also, it will be helpful to do well in your final exam, as well as this will help moreover to better understand this course content. So without any wasting time, let's share my screen and I will start discussing today's content. Okay, I think I am on screen sharing mode. So this is the font screen. So again welcoming to the problem solving session or live interactive session, the transition metal organometallics in catalysis and biology, which is the third week. We will continue this session till the end of this course. If you have any doubt, please join in the live interactive session, so by every Saturday 5 p.m. to 7 p.m. and gets your doubt cleared. I also request you to post your doubts exactly related to the course content in the portal group discussion portal. There is a tab called Q&A. You click on it and you will go to the discussion forum and post. You can also post your question there. So the first question is to the today's series is the NHC stands for. Okay, so we have seen that our olefin metastasis reaction is going through the metal carbene intermediate. So that is representing the metal as a M and double bond CH2. So this is the active intermediate for our metastasis reaction. So depending on the nature of this carbon atom, we have seen different types of carbene. One is the Fischer carbene, another is shock type of carbene, and the third one, which is maybe called as a Fischer type of carbene, but that is in a totally different kinds of carbene called NHC. This is called the N heterocyclic carbene. So NHC stands for not nitrogen hydrogen carbon, not normalized helium concentration, neon halogen compound. It is N heterocyclic carbene. So this is a special types of carbene denoted by En like this. It is there. It may be double bond. It may not be double bond. This carbene is this, and here these two nitrogen is substituted by an R group. So this is called N heterocyclic carbene, NHC. Okay. So carbene is the stabilized by an adjacent silicon or phosphorus atom is. Okay. So we have the carbene carbon C. So if we have here adjacent phosphorus or here silicon or phosphorus, this is the carbene lone pair. So when you can see that in the previous slide, when we have the carbene carbon adjacent to these two nitrogen, we are calling it N heterocyclic carbene, and this carbene is stabilized by these two nitrogen. So instead of nitrogen, if we have other types of carbene, which is called the Barton's carbene, because the person Guy Barton developed this carbene system in 1985, the way before the Arduino's carbene. So now we have seen in this slide that we have four types of carbene system: shock carbene, Fischer carbene, Arduino carbene, and Barton carbene. Now we have seen that if the silicon and phosphorus is present adjacent to this carbene carbon, we are calling is a Barton carbene. Now we can also have our discussion on other three types of carbene. Let's start. First is Fischer carbene. So Fischer carbene. So Fischer carbene is one type of carbene where we have the carbon atom. This is carbene lone pair, and two substituted. One of the substituent have the heteroatom. One substituent should be heteroatom. Another can be carbon or hydrogen. So or heteroatom X. Okay. So here the criteria is adjacent atom should be one at least heteroatom, like oxygen, sulfur, nitrogen, etc. Now the next step is shock type carbene. shock type carbene. The shock type carbene is like the same way we have carbon, and when the both the substituent is either alkyl or hydrogen so these both substituent, both adjacent substituent is hydrogen or carbon, not any hetero atom. So this is the shock type carbene. Okay, now remains is the another type is the Arduino type. Okay, so in 1991, Arduino synthesized a totally new type of carbene derived from the imidazole. So, like N, this is a imidazole. If you have the substituted in both the nitrogen adamantyl and you generate this carbene, this is called the Arduino type carbene. Okay, this is called the Arduino carbene. So this Arduino carbene is so stable that stable portable and it can be cell also, crystallizing or crystallizable, so you can see that carbene. Okay, okay, so this is called Arduino type carbene. So this carbene is nucleophilic in nature and also singlet, this also singlet carbene. Okay, I think I have explained all 4 types of carbene which was there in our options, but according to the silicon and phosphorus is the heteroatom, it will call the Barton's carbene, because the Barton invented or synthesized this in I think 1985. So after that Arduino synthesizes his carbene in Arduino carbene is this is 1991. Okay, with that I go to the next question. Arduino's bottle level carbene was developed at. So this is also recall type question, as we can see that in our first class second series that we are discussing about some industrial problem or industrial development. So we are already developing the chemistry in our academic area, but the some and then that chemistry is going to the industry. But sometimes but in academic area we are not able to understand what is the problem of the mankind, what is the problem of the human being, what are the chemical wastage we have, but industry have to deal with this. So they are always in search of treating or developing or trying to develop the new chemistry where the some useful thing or some simple thing can be converted to value added product. For that also you have seen that RAPE synthesize different kind of molecule from simply available acetylene, so and using his special RAPE glass. So like that also Arduino also synthesizes or synthesizes his chemistry in a famous institute is DuPont. So this carbene was first developed in DuPont, and this carbene is so important in homogeneous catalyst. Still now the research is going on, and it is a very hot area in organometallic compound. So the correct answer for this question is option C. This I already said that carbene that stabilized by silicon and phosphorus is Barton's carbene. Next is the product from the following conversion is. Now this reaction is a very important reaction in terms of carbene chemistry. Now we have seen that carbenes or the shock type carbene or other type carbene are highly reactive in nature, but the Arduino, this is an Arduino type carbene, is not is reactive as well as stable. So that is the two opposite word is equally applicable to this carbene moiety. So now the question is how to make it. So this is a very simple procedure to make the Arduino type carbene, and also we have seen that the Arduino type carbene or N heterocyclic carbene is always the carbon atom in adjacent to the carbon atom should be present in adjacent to the one carbon atom which is adjacent to the both the nitrogen derived from the imidazole. So this is called the preparative procedure for the Arduino carbene. So we have the adamantyl substituted imidazolium salt, and if we treat this with a base, it will generate our product desired. Now we can see that all of these not contain the carbene atom. We know that if we treat the uh, so we can apply the procedure which I discussed last time or last this is apply here. So we know that we are going to generate carbenes. So the last two options, that is the option C and option D, you can easily eliminate by option eliminating method. Now the question is we have two options, option A and option B. Now the question is where this carbene moiety will generated. Okay, where it will be generated. So because of the presence of two nitrogen atom adjacent, here it is a one nitrogen adjacent and adjacent one is another carbon, so it is not possible to stabilize through the carbon atom. So in this system will be more stabilized if the carbene is generated on the carbon atom where both the nitrogen is adjacent to it. For that option A will be right answer. So this compound, that is the adamantyl N Now Cl minus. Now you can see, you can tell me that this positive charge can be on this nitrogen instead of resonance. Yes, it is possible. Positive charge can be any of the nitrogen. That's why for this molecule the best way of representation is Ar, An, that is positive charge is circulated on both the, this is Ad, not Ar, this is Ad, this is Ad and Cl minus. So here we have one hydrogen, so the base will takes up the proton, base will takes up the proton. If you give any base like NaH minus, this NaH minus will takes up the proton and it will neutralize this to generate the carbene. As this carbene is resonating with these two nitrogen and the other double bond is there, that is unsaturated. That's why we are where we can make a goal, we can make a round circle also to denote this carbene. Okay, so this is adamantine group. If you have any metal precursor to it, so it will bind to the metal, because this um, carbene which act as a mainly, or the nucleophile, we know that carbene carbene is ambiphilic, ambiphilic in nature, but we know that the extent of nucleophilicity, electrophilicity depends. So extent of electrophilicity or nucleophilicity depends. So these types of, this more nucleophilic, or this carbon is nucleophilic in nature rather than electrophilic. More or less, if you can compare, you have to compare with some other one. So we cannot say that, but the nucleophilicity is greater for carbon act as a nucleophile. Okay. The next question is, the following canonical structure base represents A. The following, the following structure base represented A. The following structure base represented A. So we have seen that in the metastasis reaction, the intermediate for our reaction was finally came out to be true is a metal carbene intermediate. So as you know that carbene has different types known in the literature after their discovery by Fisher and Short. So the and it is a contain a metal carbon double bond. So the canonical structure can be possible for that. So as we have seen in the neutral structure, that is the structure number 2. This is the 1, 2, 3, 4. So in the structure number 2 we have seen that this is a neutral molecule. So in neutral state we have seen that the carbene is doubly bonded to metal. So that's why these are all the so when metal is bonded to carbon with the double bond, we are called as a carbene. In means double bond. When metal is bound to carbon with the 3 bond, we call as a carbine. Carbine. That is ine. Ine means 3 bond. Okay. I think I got the answer. So this is a canonical structure is best represented a metal carbene insertion. So option A will be right answer for this question. Next is the nucleophilic carbene carbon atom is present in. So in the last question I have decided different types of carbene atom or different carbene systems, that is Fisher type, shock type, another is N-heterocyclic carbene, Guy-Barton's carbene, Arduino carbene. But as we are talking in the last question that the nucleophilicity is why we have so many types of carbene. Okay, because the nucleophilicity of the carbene carbon is not same in each types of carbene. Some carbene act as a nucleophilic in nature, some carbene act as a electrophilic in nature. So before going to the options of these questions, I have to explain why which types of carbene is electrophilic and why, and what types of carbene is electrophilic and again why. So our first option is we can include the Guy-Barton's carbene, and the Arduino carbene is another types of, not another type, it is a subclass of Fisher type carbene. So let's say Fisher type carbene. So first explain the FISCHER. So we have already said that Fisher types of carbene is carbon atom containing this carbene nucleophilic lone pair, and we have two substituent. One is heteroatom, another can be carbon, hydrogen or any heteroatom. So both can be heteroatom is also possible. Okay, so now let's say we have, it is called the Fisher type. So Fisher type C carbene and we have heteroatom, let's say OR, and here we have CpH2. Okay, so now CH CHPH2. Okay, now we have this carbene in hand. So now you can see that, or if we have C carbene OR OR, R হচ্ছে alkyl group, R can be any alkyl group. R is any alkyl group. So now we can see that if we have this heteroatom, let's say oxygen, you can have sulfur also, you can have nitrogen also. So all the heteroatom in its neutral form have a lone pairs of electron, and that lone pairs of electron are more electronegative. Okay, because of that they will having a neat positive charge over the carbon atom. Because of this, Fisher types of carbene act as a electrophilic carbene. Okay, but because of the electron withdrawing effect of nitrogen, so Fisher types of carbene is electrophilic. So Fisher types of carbene is a electrophilic carbene in nature because the electron donating power is very less. That's why Fisher types of carbene, when reacts with a metal center, that metal center should have electron rich. That means metal with -1 charge, that is the negative charge on it, or metal with the low valent metal is preferred to bind with the Fisher types of carbene. Another, that is electrophilic. If you want to remember it, which carbene is electrophilic, which carbene is nucleophilic in nature, like say from the terms of a layman perspective, you can read, you can remember like this way. Let's say Fisher contain F, and electrophile contain E. So E and F are very close to each other. A, B, C, D, E, F. So Fisher electrophilic. You can remember like this. In my earlier days, I was also trying to remember this for the exam. Because in exam you cannot have the time to think all of this, like substitution, and Fisher contain heteroatom. Fisher contain heteroatom. So if you remember one, another one is automatically. So shock type of carbon is nucleophilic in nature. It doesn't contain heteroatom. The shock is no heteroatom and no heteroatom and no heteroatom, and it is nucleophilic. So from the electrophilic, if you can say it is electrophilic in nature, so it will try to bound with the metal atom. So that means it has electron deficient. Because of its electron deficiency, it will try to bound to someone which have more electron. That means metal with their low oxidation state or metal with negative electron oxidation state. And Fisher a shock type, shock has already this thing, this what is said that already it is nucleophilic. That means it is electron rich, so it will bind to a prefer to bind to a metal which is have high vacant of electron, that is electron deficient center, that is metal in high oxidation state. So shock types of carbene prefer to bind with metal atom with high oxidation state. So I think this discussion is enough to get an idea about the nucleophilicity, electrophilicity and the reactivity of Fischer and shock type. We are not here to discuss the carbene chemistry, so that's why the preliminary thing and how to remember which carbene is electrophilic and which is nucleophilic, I give a very basic idea. Okay. Go back to the question. Question is the nucleophilic carbene. So as the name suggests, nucleophilic, that means we are going to talking about the shock type of carbene, and shock type contain no hetero atom. So now first task is to look at the carbene center. So here the carbene center is this. See, it contain nitrogen, it contain oxygen. So option A, cut. Option C, this is the carbene center, it contain oxygen, another is carbon. Okay, so this is also oxygen is there, C is also cut. Option D, this is the carbene center, one content R, that means any alkyl group, that is okay, but another atom is oxygen, this is also cut. Obviously one option remain, that is option B. Here we see that this is a CH2, that is both are hydrogen. We have already mentioned there can be both carbon, there can be both hydrogen, that is this absolutely no heteroatom presence will be there in shock types of carbene, and this carbene is nucleophilic in nature. So we got the correct answer for this question. Now this question is another very important question, that the active metastasis catalyst obtained by combined by combination of, not my combination of, it should be by combination, by combination of WCl6 ET2 AlCl or ethanol is. This question another we have to recall it or remember it to get the answer correctly. Okay, the active catalyst will be, so this question is also you need to recall it. And as we are seeking the metathesis chemistry, and metathesis chemistry we know that it undergo a carbene intermediate. So the option A, which is not a carbene complex, and also option D, which is also not a carbene complex, we can easily eliminate this. So in between option B and C, we see that the carbene always form, this is the CH2, CH2, this is CH2 and this is O. This much difference only we have in this question, two options. As in the last question we have, so this carbene is Fischer type or shock type. Obviously it will be shock type carbene. Shock type carbene. Okay, shock type carbene is nucleophilic in nature. Nucleophilic in nature, and it only bind with the metal complex in the high oxidation state. So metal prefer to bind in high oxidation state. Okay, so now you can see that if you apply just simple knowledge here, it is a CH2, this is also CH2, that is the carbene which are neutral in, and this is a Cl and Cl. So Cl contribute 1 1 2, and tungsten and overall molecule is neutral. So this is only plus 2 charge. But if you compare here, this is oxygen and chloride and chloride, this is a more negative charge is attached to this tungsten. Obviously here the tungsten is more electropositive in nature. Okay, that means in more high oxidation state. So this binding possibility is not possible for this molecule. Only possibility is the option number C. So you can see that you may not know the answer for some of the question, but if you understand the topic wisely or cleverly, you can get it the right answer. So the metathesis catalyst. The metathesis catalyst key. What is the metathesis catalyst? So which undergo through a carbene intermediate. Okay. Now, so first option we cut out 2. Next option is which carbene is given. So both are given as a shock type carbene. Shock type carbene doesn't contain heteroatom. Shock type carbene nucleophilic link in nature. Nucleophilic carbene bind with the metal atom high oxidation state. Which metal in high oxidation? Tungsten in option C, in higher oxidation state. So that will be right answer. So this way you can go, or you can approach some of the question from the basic knowledge to get your answer correct. So option C here will be the right answer for this question. With that, I move to the next question, which is question number 9. This question was similar when these types of indazolium salt we are treating with NaH as a base. We also discussed this question earlier. So we have seen that if you give sodium hydride NaH to this, it will form the isolated carbene. So N will be like this, and carbene pH this will be lone pair here, which is resonating or stabilizing by these two nitrogen. Now we are giving another reagent, which is this complex. Now what will happen? See, in this reaction is a very important reaction. We have H CO5. It's not, I think not CO, it's Cr, chromium. Yes, it's chromium, Cr. Okay, so now carbonyl is neutral, and the negative charge is only coming from this hydrogen. So this is hydride. Okay, now hydride, what will add? We are giving sodium hydride. Instead of sodium hydride, you are giving the complex which contains metal hydride. So now we have the N heterocyclic carbene with pH here. So first the hydride will extract this proton and generate the carbene over here, and then this carbene is nucleophilic in nature, as I have already mentioned. So this will directly attach to this chromium and to give a chromium carbene complex. So N pH Cr CO5. Okay, so this will be the correct answer for this question. So in the carbene medium, when we have the metal, it will undergo the metallation reaction. So free carbene will easily metallate to this and give the complexes. So here option different D will be the right answer. So here different option is there, but the option D will be right answer, and option B will absolutely not right answer, because the N heterocyclic carbene is obtained on this adjacent position when both the nitrogen atom are adjacent to this carbon, because this carbon is more stabilized. Okay, if this position is blocked by something, then only we go to the other position to deprotonate and make the carbene. Okay, this is the correct answer for this question. Next question. Next question is basically the synthesis of metastasis catalyst. Okay, so if we look around in the last question which I am talking about, you can see that the eliminating option can be one of the way to get this option correct, but sometimes it may be not. Like this way, you can think that you have only this PC by 3 and piece 1 of the PCI3 is removing here and this mighty is coming, this mighty. So this mighty you just tick on it and it will be done. Okay, so this is absolutely not. Other thing like this will be not possible, because if you tick at this, there will be one carbon atom which will be missing. This carbon atom will be missing, so this is also not. Formaldehyde obviously cannot make this heterocycle. The only option remaining is option number D. So here option number D will be the right answer. So here the mechanistic pathway is really difficult to explain this, but you can try. That is, the OMe group will leave, then the hydrogen will lift over the high temperature in the solvent, and this will form the carbene to act as a ligand for this ruthenium. So this is the formation of Grabst catalyst which act. So this ruthenium, why it is important? So the earlier catalyst for this synthesis that we have seen, that all are synthesized as carbon complexes in under nitrogen atmosphere or under argon atmosphere, that is under inert atmosphere. But these catalysts can be synthesized out of the glove box, that is under air. This complex is stable. That's why that is the importance of this complex. Importance of this complex, and you can easily synthesize this using this method. So you just take this moiety, heat it in THF 80°, you will get this product, and which act as a very good catalyst in metastasis reaction, which was invented by Grafs. Okay. Next question is the correct statement about Grafs catalyst is another very question related to the Grafs catalyst. So graft catalyst, as I already said, that it is highly stable to air and moisture. Okay. So graft catalyst can be synthesized, can be used out of this glove box, out of this inert atmosphere. It is so you can cut down the point number or option number C, which is said that it is sensitive to air and moisture. So all metal carbon complexes is thought to be air and moisture sensitive, but these complex have these advantages. So option 3 is already cut. So now the remaining options is has tolerance to the functional group in substance with COOH NH2. Yes, is a functional group tolerance. It can transform the metathesis reaction. As you can see, the graphs catalyst already contains some bulky group, that is the PCY3 and all, which is PCY3 is triphenyl tricyclohexyl phosphate and all, or are very big in size. That's why it is sterically always attack the sterically perform steric lesion. They always perform the metastasis under hindered olefin, unhindered and stained olefin, which is easily undergo the metastasis reaction. It is sensitive to air, and so this is also correct option. And tri and tetrasubstitute olefin are not attracted, as again the steric region you can say that which olefins are more substituted, that are not attracted rather than the unhindered or unsubstituted olefins. So option D is also correct. So this is the so this, from this question the message is, don't try to tick one option when you get it correct. When you get the correct option at the option A, that is the first option, try to go or try to read all the options. That in the question I know that it will be mentioned which question are MCQ and which question are MCQ, but in the MSQ section, that is the multiple selection MSQ, multiple selection question, MSQ selection, multiple selection. So multiple selection question. So what can we do, that for this multiple selection question, try to read all the options. That is the best way to get the all option correct. Also there is a, in this exam there is a partial marking of MSQ, but still some mark will be lost if you don't answer just because of the reading of that question. Okay. And another thing, the next question is question number 12, the correct example of Fischer carbon complex. So thereon we are synthesize the Fischer carbon complexes, and Fischer carbon complexes are electrophilic in nature. So you can see we already have this question before, and I believe the options of this question are also same. And in this the previous question, let me go. Yes, this one. You can see that all the four options are same, but the question is different. So if you look at the option first, you will say that this is a repeat option. You just mark randomly and go. Don't do that. Please don't do that. Try to read the question. Sometimes same option can give you the different question. So here the question was nucleophilic carbene. Now our question is example of Fischer carbene. So Fischer carbene, I have already said that F, next or previous word of F is in the alphabet is E, A B C D E F. So that means Fischer carbene is electrophilic in nature, And why electrophilic? Because it contain heteroatom. Okay, so the carbene which contain the heteroatom are obviously the Fischer carbene. So you can see that here it is heteroatom, here this one heteroatom, here also this one is a heteroatom, here both are hydrogen. So instead of this, all three are right answer for this question. So here also you can see that option A, you can see option B, option C, many option on D you may not see it also, because it is option number D. The option number D. And in the exam also it will given like A, B, C and D, like this. So you can stop, you may stop at option C, but try don't stop at option 3. Read or see all the options. Okay. So here option A, B, C, D are correct answer. Next is Arduino board level carbine was A. Arduino's portable carbine was a singlet carbine, triplet carbine, tetra-substituted olefin formed by the dimerization of a singlet carbine, tetra-substituted olefin formed by the dimerization of triplet carbine. Now the question is, we have seen the Arduino carbine always previously that it is a adamantine substituted, it is an adamantine substituted En like this, and Ad adamantine substituted. This is the carbine of Arduino. And this carbine is always singlet carbine. Okay, so this is the option A is the right answer for this question. So with this I completed the today's question answer series. Okay, so with this question, that is the Arduino type question, Arduino type carbine, I completed today's question answer series. I have explained about 12 to 13 question from this week content. This week we mainly see the different types of carbines, and which is metal carbine complexes, which is a intermediate in metathesis reaction. Now after this metathesis reaction intermediate, we move to the another system, which is the alkyne metathesis. Now we are only dealing with the alkene metathesis. The metathesis reaction, an olefin metathesis reaction or double bond reaction happening between the two double bonds. Now we want to go beyond this double bond. It is the alkyne. It is the triple bond, which is not very common. Okay, so we will discuss that in the next problem solving session. So this session was conducted to answer generally the question from the student, uh, which they have during this course content, but as nobody came in today, so I continued this session, and I explain all the weak content and is much easier or as more explanation I have tried to give in. And for this, another important topic which is discussed in this week is that the types of metastasis reaction. There are different types of metastasis reaction. So I'll wait for another 2-3 minutes if anybody joined, or I will discuss the different types very briefly. Then I will close this session. Whoever will going to watch this video from the YouTube, try to join in the live discussion session. This session is to clear your doubts if you have, and to give you an idea about the pattern of the question which is going to be asked in the final examination. I hope this session, whoever watching recorded or live, will be helpful for your final exam preparation, assignment question solving. Also, if you have any suggestion regarding this session, you can also tell me in the live mode. I will try to improve according to your needs. Thank you. I'll wait for another 2-3 minutes, and then I will start discussing some different types of metastasis reaction. Then I will stop here just to wait if anybody joins or not. Okay then, as nobody joined, I have seen, and I think I want to discuss one topic, that is the types of metastasis reaction. We have already seen that the metastasis reaction undergo metal carbene intermediate. So there are different types of metastasis reaction we can address with. These are very simple, and these are only depends on how the reaction is happening. So first one is the, we can say, the self metastasis reaction. The first one is the self metastasis reaction. Okay. Cell metastasis reaction. Okay, so cell metastasis reaction is the, if you have a compound like say R1, and if it has a double bond, now these can react to it another same molecule of R1 to give the metastasis compound or metastasis reaction product, that is the R1 and this. Okay, so this is called the, this is point number 1. Point number 2, we have the cross metastasis reaction, CROSS. I know that this is already written, so still to give or generalize the idea, so that is, if you have R1 along with this R2, plus if you have R3 R4, if you have these two, it will combine to give R1 R3 R2 R4. That is also possible to give. Okay, this is called the cross metastasis reaction. So next part is acyclic diene metastasis reaction. Next is acyclic diene metastasis reaction. So in this reaction, you can see that we have a diene reaction and polymerization. So this is called acyclic diene metastasis polymerization. Acyclic diene metastasis reaction. So if you have an acyclic diene, let's say this and this, so this will undergo the polymerization reaction like this. So n number of these undergo the polymerization reaction. This is another type. If you have a ring, let's say a ring contain a double bond, and after the metastasis reaction is undergo metastasis reaction with this, and it undergo the ring this. So this is called the ring opening metastasis reaction. Okay, so this is a ring, it react to it another molecule to give, so this double bond and this double bond. So another is ring opening metastasis reaction. So another is ring opening metastasis reaction as well as the polymerization reaction. So ring opening metastasis as well as polymerize. So what we have previously, this is metastasis ring we have. Now this ring is opening but also polymerizing. So ring is opening, now this is polymerizing. So this is called the ring opening polymerization reaction, metastasis polymerization. Okay, the next six category is ring opening cross metastasis. So this reaction is very important because the substance is very important. So this all name is given by the different kind of substrate. So this is a ring plus R. So now when this reaction happen, this ring open up. Okay, this ring open up to give this thing and then R. Sorry, is R. So R will be one carbon addition. So this is called ring opening cross polymerization. Cross metastasis polymerization. Cross ring opening cross metastasis. The next is the number 7. So this is the 6. All these types of metastasis reaction we have. So this is nothing but different types of metastasis reaction which we classified according to the type of the reaction. So I think I come to the end of today's discussion series. If you have any question regarding my this video or this topic of this which I discussed today, you can ask me in the next Saturday. You can ask me in the next Saturday from 5 to 7 p.m. Try to join early and get your doubt clears. After that I will try to complete the question answer discussion session. So starting will be the your doubt clearing, and in between of the question if you have any doubt you can also ask me, and any doubt regarding the content which is in the portal or which is the assignment in the portal, please post that. When you are not in this live, you can also ask that question in the Q&A tab discussion forum. We will try to answer it as briefly or as quickly as possible. Thank you for joining or thank you for watching it. We will see you in the next Saturday 5 to 7 p.m. Thank you.